You find yourself staring into a field of scattered light, a precious few photons that have traveled more than 13 billion years to reach you. These are the first glimmers of galaxies that appear way too soon, too large and too luminous to fit into any neat timeline we ever imagined for the cosmos. It's almost as if you're witnessing the birth of entire civilizations before the universe itself had a chance to catch its breath. This doesn't feel like discovery. It feels like an unsettling invitation to question the very foundations of what we thought was true. And it calls you, here on Beyond the Universe, to look deeper, beyond what's familiar and comfortable, into the chaotic shadowlands of cosmic uncertainty. The questions don't stop here, they never do. If you're the kind of mind that can't look away from the dark, that follows the evidence even when it leads somewhere uncomfortable, then you already know where you belong. Subscribe to Beyond the Universe, because the anomalies are still accumulating, and someone has to keep watching. You begin with the simplest questions. How can these colossal galaxies exist so early in the cosmic timeline? According to everything we've painstakingly pieced together, the universe should still be in its infancy, too young for anything so enormous, so complex to have formed. Yet the evidence, the spectral signatures, the inexplicable brightness, keeps defying this expectation. There's a profound mismatch between what your eyes see and what your mind knows. Somehow time itself seems to be bending, or breaking, in the early universe. And this contradiction only deepens as you trace the faint outlines of cosmic structures sprawling across unimaginable distances. Vast clusters of galaxies appear isolated by immense voids, dark expanses so empty they absorb hope itself. These cosmic deserts challenge your understanding of how matter clumped and moved over billions of years. They tell a story of a cosmos that's more fragmented, more alien than theory would allow. You start to realize that these voids, the colossal expanses of nothingness swallowing light, may be far more than empty spaces. They might be windows into a failing narrative, one where the laws scripted in our textbooks fail beyond certain scales or epochs. But it's the subtle dance of darkness that unsettles you most. Dark matter, that elusive substance molding galaxies from behind the curtain of light, refuses to reveal its true nature. Its fingerprints appear inconsistent, sometimes stubbornly clinging to galaxies, other times seemingly absent where it should dominate. Even stranger, dark energy, the enigmatic force accelerating the universe's expansion, behaves unpredictably in the earliest epochs. According to your current models, dark energy should be a whisper in the young universe, but there are hints it roared louder than expected, warping space-time with a capricious intensity. You feel the first tremors of a cosmic rift beneath your feet, as if the universe's underlying scaffolding is fraying. At this point, your sense of wonder tees up a dawning unease. The ancient galaxies, glowing with unnatural intensity, defy timing. Massive structures emerge with baffling speed, as if cosmic evolution was skipping chapters. Then there are the vast voids, cold and empty, that consume the horizon, placing islands of matter in a frozen abyss. The anomalies in dark matter and energy hint not only at missing pieces but at possible faults in the cosmic rulebook itself. You begin to entertain a growing suspicion, a suspicion that the early universe did not unfold according to the neat, deterministic laws that physics prescribes. You peer closer, measuring the entropy, the cosmic arrow of time, trying to track the gradual decay from order to disorder. Yet the entropy in the young universe appears to behave oddly, sometimes too low for the structures already present, sometimes too high for the faint whispers of the cosmic microwave background. It's a confusing patchwork, a discordant melody, where time's arrow seems to skip beats or run backward. This unsettles you at a primordial level. If entropy, the very compass of time and existence, is unreliable, then what does that say about reality's bedrock? The expanding cosmos unfolds before your eyes as a vast ocean rushing outward, driven by forces you struggle to comprehend. But this expansion is not uniform. Anomalies emerge, unexplained alignments in the cosmic microwave background, vast regions that refuse to fit the overall pattern. These alignments suggest that the universe might not be isotropic as assumed. Instead, it might possess a kind of hidden geometry or structure unknown to science, a haunting hint that your cosmic horizon is but a veil hiding deeper, perhaps darker truths, and that may completely change what the universe actually is. Instead of an ever-expanding balloon of space and time governed by immutable laws, you begin to glimpse something far more fragile and disordered. A cosmos whose origins don't just lie in a single explosive event, but might be woven from layers of realities, dimensions, or physical principles, yet beyond human grasp. If the galaxies formed too quickly, if entropy is unreliable, If dark forces behave erratically, what you thought was stable turns out to be ephemeral. Reality itself may be an emergent phenomenon, concealing chaotic undercurrents that slip past all our instruments and equations. You feel the narrative shift subtly but irreversibly. What once felt like a grand, orderly story is fracturing into a complex maze of disturbing clues. The early universe may be a place where the ordinary rules crumble, a cosmic laboratory where space and time bend, ravel, or break apart. The evidence suggests a cosmos on the brink of inexplicability, a universe that may not only defy intuition but undermine your fundamental grasp of existence. This realization is more than scientific curiosity, it is deeply existential. You come face to face with something vast and alien, the silence of infinite voids, the flickering birth of improbable galaxies, the cold logic of entropy that seems to wobble under pressure. It's as if you've stumbled on a secret kept hidden since the dawn of time, the knowledge that the universe might be more isolated, more unstable, and unfathomably stranger than your consciousness can fully comprehend. And so you continue, drawn irresistibly forward, into a landscape filled with shadows large enough to swallow light itself. You step beyond the parameters of certainty to confront a cosmic enigma flirting with the edges of reason. This is the beginning of a voyage not only beyond known astronomy but deep into the unsettling heart of cosmic existence. Welcome to Beyond the Universe, where the very fabric of reality starts to unravel before your eyes, and where the universe itself appears to be stranger and more fragile than we ever dared to imagine. You first notice the anomaly, not in grand sweeping data, but in a single observation, a galaxy shining with impossible clarity, its light coming from an epoch so early it threatens to shatter the timeline. It shouldn't be there. It shouldn't shine this brightly, yet it does. You reflect on the countless nights when such discoveries were rare gems. Now they stand out like brazen contradictions, piling one upon another, each denying the neat progression of time and space. These ancient galaxies challenge your assumptions about how quickly matter could gather, cool, and ignite into stars. In some cases, their masses rival our Milky Way, fully formed and massive, before the universe even completed a few 100 million years. This defies the gradualist story told by current cosmological models, which posit a slow and meticulous layering of structure over billions of years. The tension builds as more observations confirm similar anomalies. It's no longer a single oddity, but a pattern defying the standard cosmic recipe. And this pushes astronomers to question, could the laws governing early cosmic evolution differ fundamentally from those today? You confront a landscape of explanations, new physics, unseen mechanisms, or something more profound that could rewrite the cosmic narrative. Compounding this is the puzzling behavior of dark matter. Instead of providing a steady gravitational framework for these early galaxies, it shows inconsistencies that unsettle even the most seasoned theorists. This mysterious substance, which supposedly controls the large-scale architecture of the cosmos, appears to misbehave in the primordial universe, sometimes mysteriously absent or ineffective. At the same time, dark energy, the force accelerating cosmic expansion in the present epoch, is thought to be negligible shortly after the Big Bang. However, subtle signals suggest dark energy's effects may have fluctuated unexpectedly in the universe's youth, perhaps driving bursts of expansion or contraction that elude current understanding. You feel the stakes rise. The simple, elegant cosmological models start to buckle under the weight of these contradictions. What was once a story of smooth expansion and orderly development becomes a saga of tension, disruption, and mystery. You find yourself peering into cracks, a cosmic web more tangled than ever imagined. The isolated galaxies and immense voids deepen the unease. These gaps are not mere absences, but regions that seem to resist matter itself, expanses where light dims to near extinction. The further out you gaze, the more these voids loom like enormous wounds in the cosmic fabric. They seem to erode the principle that matter spreads evenly across space, suggesting instead a universe growing increasingly fragmented and lonely. Questions multiply. Are these voids natural consequences of cosmic evolution? Or are they symptoms of unknown processes undermining space itself? Could these anomalies in structure be signs of physical laws bending, or cosmic boundaries bleeding into unknown realms? You start to glimpse a universe that is isolated not just by scale and distance, but by a fundamental disconnection between matter, energy, and time. As entropy looms, tracing the irreversible march of disorder and decay, its behavior in the early universe appears precarious. You confront an unsettling possibility, that the conditions thought to guarantee steady entropy increase might have exceptions, even reversals. under the strange conditions of primordial space-time. This sends your thoughts drifting toward the ultimate question: what is the arrow of time if its foundation is loose? If entropy is not as reliable a guide backward as we believe, could time itself be emergent, fragile, or multivalent? It is no longer just about stars and galaxies. It is about the skeleton of time, the essence of cause and effect. The ever-expanding universe, once a symbol of hope and progress, now feels more like a cosmic labyrinth growing in complexity and menace. Large-scale anomalies in the cosmic microwave background, once dismissed as quirks, gain new weight as potential signs of hidden structures or deeper cosmic orders. The universe might harbor coherent alignments or patterns that ripple across billions of light-years, defying the assumption that space is uniform and random. You realize you are confronting a cosmos where everything, the distance, the matter, the flow of time, may be arranged according to principles beyond our current grasp. A hidden geometry, a cryptic code, a fundamental instability lurking beneath the veneer of smooth cosmic expansion, and the contradictions multiply relentlessly. Galaxies too old, voids too vast, dark energy too wild, entropy too uncertain, a cascade of anomalies blurring the familiar outlines of reality. You begin to see anomalies not as exceptions, but as evidence of a fractured cosmic order. This is where certainty collapses. This is where you begin to question everything you thought you knew about the universe's origins and nature. The early universe's inexplicable speed of evolution might be a symptom of deeper mysteries, unseen dimensions, broken symmetries, or physical laws that evolve alongside the cosmos itself. Your curiosity deepens into unease. If the universe is not stable, if its early history is written in cryptic contradictions, what does that say about your place in it? About the possibility that the very fabric of existence, which feels continuous and dependable, might be unstable or incomplete? Beyond the universe, the journey beckons you further into the cosmic maelstrom, into realms where familiar physics loses hold, and the universe's true nature begins to dissolve into shadow. What starts as awe at the first light turns toward a growing vertigo, a haunting confrontation with the unknown. The cosmos is no longer a safe harbor of laws and constants. It is a vast, unsettling expanse where time itself might flutter and break. Galaxies emerge as impossible artifacts, and the dark forces steering existence reveal more questions than answers. As you prepare to dive deeper, you sense the eerie pulse beneath it all. The universe might be isolated not only in space, but in understanding, running on rules that elude you, and perhaps always will. There is a particular kind of silence that only the deepest cosmos can produce. Not the silence of an empty room or a quiet night, but a silence so absolute and so ancient that it carries within it the weight of billions of years of unwitnessed events. You begin to feel it now, pressing against the edges of your comprehension, as the anomalies you have already encountered start to arrange themselves into something that feels less like coincidence and more like a pattern. And patterns, in cosmology, are never innocent. They are either the signature of understood physics or the fingerprints of something that has no name yet. Consider the galaxy designated JWST Z13-0. You are looking at a structure that existed when the universe was barely 320 million years old. To place that in perspective, the universe is approximately 13.8 billion years old. This galaxy emerged in the equivalent of the first 2.5% of cosmic time. But the truly disquieting detail is not merely its age. It is its completeness. It is not a proto-galaxy, a tentative clump of primordial gas struggling to hold itself together. It is a fully realized structure, luminous and massive, behaving as if it had been given billions of years it simply did not have. You stare at it, and the numbers refuse to reconcile. The mathematics that governs how gas collapses, how stars ignite, how stellar generations must live and die to forge the heavy elements that galaxies need to grow. All of it demands more time, far more time. And yet here it stands, ancient and impossible, glowing across 13 billion light-years of intervening space. But it gets worse. JWST Z13-0 is not an isolated case. The James Webb Space Telescope, since its deployment, has returned images that have forced cosmologists into deeply uncomfortable conversations. Dozens of galaxies, each carrying a redshift signature that places them in the universe's earliest chapters, appear not as the dim, embryonic hazes that models predicted, but as bright, structured, and massive objects. Some of them contain stellar populations that appear older than the surrounding universe should permit. Not slightly older, dramatically, inexplicably older. It is as if you opened a book and found chapters that were written before the book itself existed. You find yourself tracing the logic backward. The standard cosmological model, known formally as Lambda CDM, a framework that has served as the backbone of cosmic understanding for decades, predicts a specific sequence of events. After the Big Bang, the universe expanded and cooled. Gravity slowly coaxed dark matter into filaments and halos. Ordinary matter followed those gravitational channels, condensing into the first stars and then into the first modest galaxies. These early galaxies were supposed to be small, irregular, chemically primitive. Over billions of years, through mergers and accretion and the slow accumulation of mass, they were supposed to eventually become the grand spirals and ellipticals we observe in the mature universe. This was the orderly progression. This was the timeline. And the Webb telescope is now suggesting, with mounting and uncomfortable clarity, that the timeline is wrong. The deeper you look, the more unsettled the ground beneath you becomes. Because the problem is not limited to individual galaxies appearing too early. There is a structural dimension to these anomalies that extends the mystery into something far larger and far stranger. Across the observable universe, astronomers have cataloged what are known as large-scale structures, the cosmic web of filaments, walls, and nodes that organize matter across hundreds of millions of light years. In this web, galaxies cluster along glowing threads of gas and dark matter, while between those threads lie the voids. But recent surveys of the deep sky have revealed structures whose sheer scale defies the time available for their formation. The Hercules Corona Borealis Great Wall is one such structure. Stretching across an estimated 10 billion light-years, it is among the largest known formations in the observable cosmos. But its existence poses a profound problem. According to the Standard Model, structures of this scale should not exist. The universe has simply not had enough time, not enough gravitational momentum, not enough sequential merging of smaller structures to assemble anything this enormous. To build a wall of galaxies 10 billion light-years across, the universe would need to have started that assembly process before it had even finished its first formative epochs. The mathematics does not permit it. And yet there it is, hanging in the data like a ghost that defies the laws meant to explain it. What makes this particular anomaly so intellectually disorienting is what it implies about causality. For a structure to form coherently across such a distance, the various parts of it would need to have been in some form of causal communication, meaning that information, or at minimum gravitational influence, would have had to cross that distance during the formation process. But the speed of light places a hard ceiling on how fast any influence can travel. In a universe 13.8 billion years old, no signal can have crossed more than 13.8 billion light-years. A structure 10 billion light-years wide should therefore sit right at the edge of what causal physics permits, and several other detected structures push even further beyond that boundary. You begin to feel the logical ground give way beneath you, because what you are confronting is not just a mystery about galaxies. You are confronting a possible violation of the causal architecture of the universe itself, and this leads to something more disturbing. The assumption that the universe is roughly the same in all directions, what cosmologists call the cosmological principle, has been one of the most sacred axioms of modern physics. It is not merely a convenient assumption, it is the philosophical and mathematical foundation on which virtually every cosmological calculation is built. The universe, according to this principle, has no preferred direction, no special center, no hidden asymmetry. Matter on sufficiently large scales should be distributed with statistical uniformity. The cosmos should look essentially the same regardless of which direction you observe. But the growing inventory of superstructures, of anomalous alignments, of voids too vast and walls too wide, is quietly and relentlessly eroding that assumption. There is a particular feature in the cosmic microwave background, the faint thermal echo of the early universe imprinted across the entire sky, that has troubled physicists for years. It is called the axis of evil, a name given not for dramatic effect, but for the genuine unease it inspires. Certain low-frequency temperature fluctuations in the CMB align with suspicious precision along a preferred cosmic axis. They correlate impossibly with the geometry of our solar system's orbital plane and with the distribution of matter in the local universe. In a truly random and uniform cosmos, this alignment should have a probability so vanishingly small that it ought to be impossible. Yet there it is, embedded in the oldest light in existence, suggesting that either our measurements are flawed in a specific and consistent way, or the universe itself carries an intrinsic directionality that no current theory accounts for. You feel something shift in your perception at this point, because you started this journey looking at galaxies, distant, beautiful, abstract objects suspended in the void. But now you are being forced to confront the possibility that the void itself, the backdrop of space against which all of this unfolds, may not be the neutral, featureless expanse you assumed. The very geometry of the universe, its large-scale topology, its directional structure, its distribution of emptiness and mass, may be shaped by something that lies beyond the current reach of cosmological theory. And once you begin to suspect the geometry, every measurement made within that geometry becomes suspect. Every number, every distance, every redshift, every timeline, all of it now carries a shadow of potential error. But that is not the real problem. The real problem lies in what the anomalies taken together begin to imply about the nature of the laws themselves. You have been operating under the assumption that the fundamental constants of physics, the speed of light, the gravitational constant, the fine structure constant that governs electromagnetic interactions, are exactly that, constant, fixed, unchanging across time and space. The equations of general relativity and quantum mechanics that underpin all of cosmology depend on this constancy. Without it, every prediction, every model, every interpretation of observed data becomes unreliable in ways that are nearly impossible to quantify. Yet there is now a body of observational evidence, contested but persistent, suggesting that at least some of these constants may have been slightly different in the early universe. The fine structure constant, which determines the strength of electromagnetic interactions and therefore influences every aspect of atomic behavior, has been measured at cosmological distances using the spectral absorption lines of quasars. These measurements probe the physics of the universe as it existed billions of years ago, and a subset of them suggests that the constant's value may have been marginally different in the ancient cosmos. The discrepancies are small but statistically significant in certain datasets. If true, even a fractional variation in this constant during the universe's earliest epochs could have altered the rate at which stars formed and died, the rate at which heavy elements were synthesized, and consequently the rate at which galaxies grew. It would, in other words, provide a mechanism, a deeply unsettling one, for the impossible galaxies you are observing to have formed faster than the standard model permits. You sit with that for a moment. The idea that the physical constants might evolve, that the very rules of nature are not eternal and invariant, but are themselves subject to some deeper unknown principle, is not merely a technical adjustment to cosmological models. It is a philosophical earthquake. It means that the universe you are trying to understand may have been, in its early chapters, operating under a different version of physics, not radically different perhaps, not a universe unrecognizable to science, but different enough that the equations you apply today may be systematically misrepresenting what happened then. And if the laws themselves were different, then the entire edifice of inferred cosmic history, every timeline, every age, every distance calculated from the behavior of light and matter, rests on a foundation that may be subtly, but profoundly wrong. There is a name for the growing tension between what the standard model predicts and what observations reveal. Cosmologists call it the Hubble tension, and it has become one of the most actively debated crises in modern physics. The Hubble constant is the number that describes how fast the universe is expanding. It should, in principle, be measurable by multiple independent methods, all yielding the same result, but they do not. Measurements taken from the cosmic microwave background, looking backward to the early universe, consistently yield a lower value than measurements taken from the local universe using Cepheid variables, supernovae, and gravitational lensing. The discrepancy is small in absolute terms, but statistically, it is enormous. The two values should agree if the standard model is correct. Their persistent disagreement is either the result of systematic measurement errors that no one has been able to identify despite years of effort, or it is a genuine signal that the universe is behaving differently at different epochs, that the expansion rate itself has changed in ways not accounted for by current theory. And this leads somewhere you may not want to go, because if the expansion rate has changed unexpectedly, then the age of the universe derived from that rate is also uncertain. The familiar figure of 13.8 billion years, the number that anchors every timeline, every age calculation, every interpretation of when the first galaxies could have formed, may be wrong. Not wildly wrong, perhaps, but wrong enough to matter. Wrong enough that galaxies dismissed as impossibly ancient might have had more time to form than the standard timeline allows. wrong enough that structures dismissed as impossibly large might have had more opportunity to assemble. The Hubble tension, if it reflects a genuine flaw in the Standard Model rather than a measurement artifact, does not merely adjust a number. It destabilizes the entire chronology of the cosmos, but it goes deeper, because the Hubble tension is not the only tension. Sigma 8, another cosmological parameter that measures the clustering of matter on large scales, also shows a discrepancy between what early universe measurements predict and what late universe observations reveal. The universe, according to early universe data, should be slightly more clumped, slightly more structured than it actually appears to be when you measure it directly in the present cosmos. Once again, the two ends of the timeline disagree. The early universe and the late universe are telling different stories about the same cosmos, and the gap between those stories is growing wider as measurement precision improves rather than narrower, which is what you would expect if the discrepancies were merely artifacts of imprecise instruments. You are now standing at the edge of something that feels genuinely vertiginous. You began this journey with a single impossible galaxy, and you have arrived at a place where the core parameters of the universe, its age, its expansion rate, its matter distribution, are all simultaneously in tension with themselves. The anomalies are no longer isolated curiosities. They are forming a constellation of contradictions, and that constellation is beginning to look like the outline of something fundamentally unknown. Not unknown in the way that a new particle is unknown, waiting to be discovered and slotted neatly into the existing framework. Unknown in the way that a crack in a load-bearing wall is unknown, a sign that something structural, something beneath everything visible, may be compromised. Consider what dark matter is supposed to do in this picture. The Standard Model assigns dark matter the role of cosmic architect. It was dark matter's gravitational skeleton that first began to gather and concentrate in the period after the Big Bang, pulling ordinary matter into its halos and seeding the formation of galaxies. Without dark matter forming those initial structures, galaxies could not have assembled on the timescales observed, even the timescales of the old, pre-Webb Standard Model. Dark matter was the solution to the timing problem of galaxy formation. But now the timing problem has become so acute, so dramatically accelerated by Webb's observations, that dark matter in its current theoretical form no longer fully solves it. The halos that dark matter is supposed to form, according to simulations, do not build up rapidly enough to explain galaxies that are already massive and complex at redshifts greater than 10. Something either helped dark matter work faster, or something replaced the role it was supposed to play entirely. This opens a wound in cosmological thinking that has not yet closed, because if dark matter did not do what it was supposed to do in the early universe, then what did it do? And if it did something different, then every simulation, every model, every predicted distribution of galaxies and voids that relies on the standard dark matter prescription is potentially miscalibrated. The maps of the cosmic web you have been using to interpret observational data may be inaccurate not just in fine detail but in fundamental character. You may have been reading a map of the wrong universe, and the candidates proposed to replace or supplement standard dark matter each carry their own unsettling implications. Warm dark matter, which consists of particles moving faster than cold dark matter, would suppress the formation of small structures and potentially accelerate the collapse of larger ones, which fits some observations but creates new tensions elsewhere. Fuzzy dark matter, composed of ultralight particles governed by quantum wave mechanics on astronomical scales, would impose a granular structure on the cosmic web that might explain some anomalies but requires physics with no experimental foundation. Self-interacting dark matter would alter how halos form and concentrate in ways that could explain certain galaxy dynamics, but complicates the entire large-scale picture. Each alternative moves you further from certainty and deeper into a labyrinth of competing models, none of which fully resolves the contradictions, all of which introduce new ones. You pause here, not because the journey is ending, but because this moment deserves stillness. You have moved from a single anomalous galaxy to a fundamental uncertainty about the nature and behavior of the substance that makes up the majority of all matter in the cosmos. This is not a minor revision. This is the kind of conceptual upheaval that, historically, has preceded entire paradigm shifts in science. Moments when the accumulation of anomalies grows large enough that the existing framework can no longer absorb them without fracturing. You are not witnessing the refinement of a theory. You are witnessing the trembling of one, and dark energy, the even more mysterious counterpart, the invisible pressure that drives the accelerating expansion of the universe, is equally troubling in its early universe behavior. Current models treat dark energy as something very close to a cosmological constant, a fixed property of space itself that generates a uniform repulsive pressure throughout the cosmos. This constant value fits the late universe data reasonably well, though with growing cracks. But in the early universe, any variation in dark energy, any departure from perfect constancy, would have had enormous effects on the conditions under which galaxies formed. Even a slight fluctuation in the dark energy density in the first billion years of cosmic history could have altered the balance between gravitational collapse and cosmic expansion in ways that cascade through the entire subsequent timeline. And recent measurements from surveys like DC, the Dark Energy Spectroscopic Instrument, have produced early hints that dark energy may not be constant after all, that it may evolve, that it may have been stronger in the past, or weaker, or oscillatory, in ways that no current model predicts and no current theory satisfactorily explains. If dark energy evolves, then the cosmological constant, one of the most fundamental quantities in physics, intimately tied to the quantum vacuum energy of space itself, is not constant, and that particular realization opens a philosophical abyss, because the cosmological constant is already one of the most troubled numbers in physics. The value measured observationally is approximately 120 orders of magnitude smaller than what quantum field theory naively predicts it should be. This discrepancy, sometimes called the worst prediction in the history of physics, has never been satisfactorily explained. It requires an almost perfect cancellation between enormous positive and negative quantum contributions, a cancellation so precise that it strains every intuition about what is natural or expected in a physical theory. The fact that dark energy may now be showing signs of evolution does not solve this problem. It deepens it, because a truly constant cosmological constant, however puzzling, is at least philosophically tidier than one that changes in ways dictated by unknown dynamics. You feel the weight of all of this pressing down now, not with the clean, clarifying weight of understanding, but with the dense, suffocating weight of compounding uncertainty. You have not been given more answers as you have ventured deeper. You have been given more questions, each larger and more structurally threatening than the last. The galaxy that should not exist became a collection of galaxies that should not exist, which became an inconsistency in the cosmic web, which became a tension in the expansion rate, which became a doubt about the nature of dark matter, which became a tremor in the foundations of dark energy itself. At each step, the problem has not simplified, it has amplified. And somewhere at the bottom of all this escalating uncertainty, there is a question that you have been circling without quite confronting directly, a question that the evidence is beginning, slowly and reluctantly, to force into the open. It is not merely, does the standard model need revision? That question is already answered implicitly by everything you have examined. The answer is clearly yes. The deeper question, the one that transforms this from a scientific puzzle into something that deserves to be called existential, is this: what if the rules themselves, the physical laws that govern this universe, are not the kind of laws we think they are? What if they are not universal in the deepest sense and not absolute, not timeless, not independent of context, but are instead emergent properties of a more complex underlying reality that we have not yet even begun to detect? That question does not have a comfortable answer, and the fact that it can be asked seriously, with genuine scientific motivation, derived from real observational data, is perhaps the most unsettling thing you have encountered so far in this descent. Because if the laws are emergent, if they arose from some deeper substrate the way temperature arises from the collective motion of molecules, then the universe is not governed by eternal principles. It is governed by circumstances, and circumstances can change. The very idea that physical laws might be local phenomena, contingent upon unknown deeper variables, cracks open a panorama of eerie possibilities. You start to imagine a cosmos where the constants you rely on fluctuate or vary in different regions or epochs. A universe not governed by fixed mathematical formulas, but by rules that evolve, transition, or maybe even flicker in and out of existence like unstable ephemera. The comforting coherence you've once attributed to the universe begins to dissolve, much like those ancient galaxies that refuse to fit the expected timeline. And if the foundational laws evolve, then what does causality even mean? Cause and effect require a stable framework to operate within. If the very scaffolding of space-time is fluid, if constants like the speed of light or the gravitational constant vary with place or time, the past, present, and future may lose their sacred ordering. You feel the unease creeping in. Without stable causal chains, can you truly say that the early universe happened before the late universe, or that the galaxies evolved because of gravitational collapse? Or did they simply materialize as part of an entirely different regime with rules foreign to your understanding? You reach deeper into the void and find shadows where answers should be. The cosmic voids, those vast, chilling expanses empty of galaxies, take on new, more menacing significance. Instead of being simple gaps, they might be regions where the usual physical laws are suppressed or replaced. Maybe they are bubbles of alternate vacuum states, fragments of diverging cosmic domains where the parameters of nature vary wildly or degrade completely. In such voids, not only are galaxies sparse, physics itself may be different, unstable, or even fundamentally broken. You feel as if the universe is a patchwork quilt of physical possibility, stitched with imperfections and ruptures whose edges you can glimpse, but not cross. The isolation of large-scale cosmic structures from each other gains a chilling tone in this context. No longer can you think of galaxies simply as isolated islands in static space. Instead, they become disconnected outposts in a fractured reality, each living under slightly different rules, subtly untethered from every other. The cosmic loneliness you imagined deepens. It is not just emptiness you feel in the voids, but a disconnection from coherence itself. You instinctively look for salvation in established theory. Perhaps a deeper symmetry or a hidden dimension could reconcile these contradictions. There are whispers in the corridors of theoretical physics, ideas about higher dimensions, multiverses, and holographic possibilities, hinting that what you see is only a shadow of a far vaster reality. But these remain words in the air, conjectures barely anchored to observation, their mathematics tantalizing yet maddeningly incomplete. They offer tantalizing glimpses but no firm footing. They may point toward a future understanding, or they may be the mirages of a mind struggling to impose sense on the nonsensical. Meanwhile, entropy, the cosmic clock ticking steadily toward decay, perplexes you further. If the universe's expansion is accelerating uncontrollably, as the dominance of dark energy suggests, the ultimate fate may be one of heat death, a cold, dark oblivion where all energy gradients vanish, and no work or structure can persist. But the discrepancies in entropy measurements compel you to ask, is the arrow of time even well defined? Or is the universe trapped in some liminal state where time's flow wavers, stalls, or reverses in ways you cannot yet measure? Such a question does not arise in laboratory physics where thermodynamic laws reign with brutal clarity, but in the vast empty reaches between the ancient impossible galaxies and the yawning voids, it peers at you from the dark, intangible, and profoundly unsettling. And this leads to a reflection you can barely voice aloud. If time itself is unreliable, if physical laws are mutable, then are the stories we tell ourselves about the origin of everything just human convenience? The Big Bang, inflation, dark matter, dark energy, concepts that once seemed monumental and profound, now feel like fragile scaffolds held up by unseen hands, subject to collapse or replacement. The universe might not have a single linear origin story, but instead a patchwork of cosmic histories, none of which fully encapsulate reality, but all of which offer glimpses of a deeper, more disturbing truth. You contemplate the expanding universe viewed from this perspective. The cosmic horizon, often imagined as a boundary beyond which the universe is unknowable, may itself be a dynamic, permeable membrane. Beyond it could lie domains where physics takes entirely different forms, regions where space and time themselves dissolve or bounce back into existence. The familiar expanding space might be just a surface on a complex topography deeper than light or thought can penetrate. You feel yourself caught in the vastness of speculation, but these are not baseless imaginings. They emerge organically from the accelerating accumulation of anomalies, converging to suggest that the universe is no static, eternal fabric, but rather a complex, unstable construct. Your attention pulls to the concept of isolation again, this time in a fundamental sense. Not only are vast regions empty or contain unreachable galaxies, but the very information connecting different parts of the universe seems severed. The idea that you could one day map, understand, or even communicate across the entire cosmos collapses in the face of cosmic horizons, accelerating expansion, and barrier-like voids. The universe becomes fragmented into causally disconnected bubbles or pockets, each evolving along its own trajectory, oblivious to the others. This sense of isolation has a haunting resonance beyond physics. It mirrors the existential human experience, your own existence confined to a fragile, isolated world in an overwhelmingly indifferent cosmos, cut off from answers and ultimate meaning. The universe's empty vastness and impossible beginnings become a metaphor for an isolation so profound that it challenges rational thought. a solitude so absolute it resonates as a deep, cosmic alienation. As you dive even deeper, the unsettling pattern becomes clear. Each new discovery not only defies your expectations, but undercuts the foundations of scientific certainty itself. The universe that once inspired awe, because of its grandeur and comprehensibility, begins to inspire something darker. What if the cosmos is fundamentally unknowable? What if the pursuit of knowledge is not a path toward understanding, but a spiral into more profound mystery? This thought brings a new kind of terror. You realize that the comforting boundary between the known and the unknown, that line scientists always assume can be pushed back steadily through observation and theory, is becoming unsteady. The unknown realms you are glimpsing may be vast, not just physically but epistemologically inaccessible, teetering at the very edge of what any observer can possibly comprehend or measure. You wrestle with the implications of cosmic loneliness paired with systematic confusion. If structures form too rapidly for physics to explain, if constants may vary, if regions of space differ fundamentally in their nature, the notion that the universe is a single unified object governed by one set of unified laws seems less plausible than ever. Instead, what you see is a fractured, fragmented cosmos, one that might be more like a collection of overlapping realities than a single predictable entity. And as this realization settles, it reframes your own perspective. You are no longer simply an observer collecting data. You become a witness to cosmic fragility, a fragility that isn't just scientific, but existential. The cosmos may be far more delicate and unstable than previously imagined, a precarious construction that manages to sustain complexity only fleetingly amidst the background drift of entropy and expansion. This fragility extends to time and space themselves. You begin to consider models suggesting that space-time is not continuous but granular, a quantum foam bubbling beneath the apparent smoothness of reality. The notion that time and space might emerge from a quantum substrate is no longer a fringe idea but a serious contender to explain cosmic anomalies. Such a universe doesn't flow unbroken from past to future, but is patched together in quanta of space and moments, stitched by probabilities and fluctuations, rather than definite causality. This leads you to question what it means for something to truly exist in such a strange universe. If space-time is emergent and physical laws are fluid, then what you perceive as here and now are just transient phenomena in a deeper sea of cosmic. This leads you to question what it means for something to truly exist in such a strange universe. If space-time is emergent and physical laws are fluid, then what you perceive as here and now are just transient phenomena in a deeper sea of cosmic possibility. Existence itself becomes conditional, dependent on the local configuration of whatever substrate underlies reality. You are not standing on solid ground. You are floating on a surface tension that could break at any moment, revealing depths you cannot fathom. The ancient galaxies staring back at you from the edge of time take on a new character in this light. They are not merely objects that formed too quickly. They are witnesses to a different regime of physics, survivors from an epoch when the universe operated under rules that may have been fundamentally alien to the present. Their light carries information encoded in a language you are only beginning to suspect exists, let alone decode. Each photon that reaches your instruments has traveled through billions of years of expanding, evolving space. And the question becomes, has the space itself changed the message? Has the light been altered not just by redshift, but by passage through regions where the electromagnetic constant, the vacuum energy, or even the dimensionality of space itself was different? You consider the cosmic microwave background again, that faint glow permeating the entire sky, the oldest light in the universe. It has always been treated as a pristine snapshot of the universe at 380,000 years old, a moment when the cosmos became transparent and photons could finally travel freely. But if the early universe was governed by different physics, if constants varied or spacetime itself was structured differently, then the CMB may not be the clean, interpretable signal you have assumed. It may be a palimpsest, a document overwritten and corrupted by unknown processes, carrying within it not just the echo of the Big Bang, but the fingerprints of transitions, phase changes, or even collisions with other cosmic domains that have no place in the standard narrative. The axis of evil in the CMB, that troubling alignment of temperature fluctuations, refuses to fade from your thoughts. It sits there in the data like a scar, a directional asymmetry that should not exist in a universe born from a perfectly symmetric explosion. Some have tried to dismiss it as a statistical fluke, an artifact of how the data is processed, or a coincidence of cosmic variance. But the alignment persists across multiple independent analyses, and its correlation with local structures that should have no causal connection to the CMB whatsoever, suggests something deeper and more disturbing. It suggests that the universe may have a preferred direction, a cosmic axis around which certain properties are organized, and if the universe has a preferred direction, then it is not isotropic. And if it is not isotropic, then the cosmological principle, the assumption that the universe looks the same in all directions, is violated. And if that principle is violated, then every cosmological calculation that depends on it, which is to say nearly all of them, is built on a false foundation. You feel the vertigo intensifying. The ground is not just unstable, it is actively dissolving beneath you. Each new piece of evidence does not clarify the picture, but fractures it further, scattering the fragments into configurations that resist coherent interpretation. The universe is not revealing itself to be more complex in a manageable way, the way a puzzle becomes clearer as you add pieces. It is revealing itself to be more complex in a way that suggests the puzzle itself may be impossible, that the pieces may not fit together at all, that you may be trying to solve something that has no solution within the framework of human cognition. And this brings you to a threshold you have been approaching but have not yet crossed. The threshold where scientific inquiry transforms into something closer to existential confrontation. Because the anomalies you are cataloging are not just technical problems waiting for technical solutions. They are symptoms of a deeper crisis, a crisis in the relationship between the observer and the observed, between the mind that seeks to understand and the reality that resists understanding. The universe is not simply hiding information from you. It is presenting you with information that may be fundamentally incompatible with the conceptual tools you possess to interpret it. Consider what it means to measure distance in cosmology. You do not have a cosmic ruler. You cannot stretch a tape measure across billions of light years. Instead, you infer distance from the behavior of light, from redshift, from the brightness of standard candles like supernovae, from the angular size of known structures. But every one of these methods depends on assumptions about how light behaves, how space expands, how objects evolve over time. If any of those assumptions is wrong, then the distances are wrong. And if the distances are wrong, then the timeline is wrong. And if the timeline is wrong, then the entire narrative of cosmic history collapses into uncertainty. The ancient galaxies may not be ancient at all, or they may be far more ancient than you think, or the very concept of ancient may lose meaning in a universe where time itself is not a universal, well-defined quantity. The same applies to mass. You infer the mass of galaxies from their gravitational effects, from the rotation curves of stars, from the motion of gas clouds, from gravitational lensing. But those inferences depend on the assumption that gravity behaves according to general relativity across all scales and epochs. If gravity is modified at large scales, or if it was different in the early universe, then the masses you calculate are systematically wrong. And if the masses are wrong, then the entire inventory of matter in the universe, the balance between ordinary matter, and dark energy, is wrong. The cosmic census becomes unreliable, and with it, every conclusion drawn from that census. You are now staring into an abyss of compounding uncertainty, where every measurement depends on assumptions that themselves depend on other measurements, creating a web of interdependence so tangled that pulling on any single thread threatens to unravel the entire structure. This is not the healthy skepticism that drives scientific progress. This is something more corrosive, a suspicion that the entire edifice of cosmological knowledge may be built on circular reasoning, on assumptions that validate themselves only because they are embedded in every step of the analysis. But it goes deeper still, because even if you could somehow disentangle all the assumptions, even if you could measure distances and masses and ages with perfect accuracy, you would still be left with the problem of interpretation. The universe does not come with labels. It does not tell you what dark matter is or what dark energy is, or why the constants have the values they do. You impose interpretations on the data, and those interpretations are shaped by the theories you already believe, by the mathematical frameworks you have been trained to use, by the philosophical commitments you may not even be consciously aware you hold. The act of observation is never neutral. It is always an act of translation, of forcing the raw, chaotic data of the universe into categories and narratives that make sense to human minds. And if the universe is genuinely alien, if it operates according to principles that do not map cleanly onto human intuition or human mathematics, then that translation may be introducing distortions so profound that the translated version bears little resemblance to the original. This is where the isolation becomes not just physical, but epistemological. You are isolated not just by distance, not just by the expansion of space or the vastness of the voids, but by the fundamental gap between what the universe is and what you are capable of knowing about it. The cosmos may be sending you signals, but you may lack the sensory apparatus, the conceptual vocabulary, the cognitive architecture to decode them. You are like a creature trying to understand color through sound, or time through taste, attempting to map one domain of experience onto another that is fundamentally incommensurable, and yet you cannot stop. The human mind, confronted with mystery, does not retreat into comfortable ignorance. It probes, it questions, it builds models and tests them against reality, even when reality refuses to cooperate. This drive is both your greatest strength and your deepest vulnerability. It propels you forward into the unknown, but it also exposes you to the possibility that the unknown may be larger, stranger, and more hostile to understanding than you ever imagined. You turn your attention now to the concept of cosmic inflation, that brief, explosive expansion thought to have occurred in the first fraction of a second after the Big Bang. Inflation was proposed to solve several problems in the standard Big Bang model: the horizon problem, the flatness problem, the monopole problem. It does so by positing that the universe underwent a period of exponential expansion, driven by a hypothetical inflaton field, that smoothed out irregularities and set the initial conditions for everything that followed. Inflation has been remarkably successful in explaining the large-scale uniformity of the universe and the small-scale fluctuations that seeded galaxy formation, but it has always been a theory with uncomfortable features. The inflaton field has never been detected. The mechanism that started inflation and the mechanism that stopped it are both poorly understood, and the theory predicts almost inevitably the existence of a multiverse, an infinite ensemble of causally disconnected universes, each with potentially different physical laws and constants. The multiverse is not a comfortable idea. It is not something you can test or observe directly because, by definition, the other universes are beyond your cosmic horizon, forever inaccessible. It transforms cosmology from a science that studies the universe into a science that studies one universe among an infinite number, and it raises the question of whether the laws and constants you observe are fundamental or merely environmental, accidents of the particular cosmic bubble you happen to inhabit. If the multiverse is real, then the search for a single, unified theory of everything may be misguided. There may be no single set of laws that governs all of reality, only a vast landscape of possibilities, each realized somewhere in the infinite expanse of the multiverse. But the multiverse also offers a potential explanation for some of the anomalies you have been confronting. If the early universe was not a single, smooth expansion, but a chaotic, bubbling froth of inflating regions, each with slightly different properties, then the large-scale structures, the impossible galaxies, the directional asymmetries, all of these could be remnants of that primordial chaos. The universe you observe might be a patchwork, stitched together from domains that inflated at different rates, under different conditions, with different effective laws. The seams between those domains might still be visible in the data, encoded in the alignments and anomalies that refuse to fit the standard model. This is a seductive idea, but it is also a dangerous one, because once you allow for the possibility that different regions of the universe have different properties, you open the door to a kind of explanatory nihilism. Any anomaly can be explained away as a boundary effect, a relic of a domain transition, a consequence of local variation in the laws. The theory becomes unfalsifiable, capable of accommodating any observation, and therefore incapable of making meaningful predictions. It ceases to be science in the traditional sense and becomes something closer to metaphysics, a framework for thinking about the universe that is intellectually rich but empirically empty. You wrestle with this tension. On one hand, the anomalies demand explanation, and the multiverse offers a way to explain them without abandoning the core framework of inflation and quantum field theory. On the other hand, accepting the multiverse feels like giving up, like admitting that the universe is too complex, too chaotic, too fundamentally unknowable to be captured by a single, elegant theory. It feels like a retreat from the Enlightenment dream of a cosmos governed by rational, discoverable laws into a postmodern landscape of irreducible plurality and contingency. And yet, the data does not care about your philosophical discomfort. The data simply is. The galaxies are too old, the structures are too large, the voids are too empty, the constants may be varying, the expansion rate is inconsistent, the CMB has unexplained alignments. These are facts, or as close to facts as cosmology can produce, and facts demand interpretation, even when the interpretation leads you into territory that feels intellectually and emotionally treacherous. You consider the role of dark matter once more, but now through a different lens. What if dark matter is not a single substance but a category, a placeholder for a variety, but the loneliness of understanding? You are alone not just in space but in meaning, isolated by the gap between what you can observe and what you can comprehend, between the universe as it is and the universe as you are capable of knowing it. And there is no bridge across that gap, no way to close the distance, no final revelation that will make everything clear. There is only the endless, vertiginous descent into deeper and deeper layers of mystery, each one revealing not answers but more questions, each one pushing you further from the solid ground of certainty and deeper into the abyss of the unknown. And yet, even here, even at the edge of comprehension, you do not turn back. You cannot, because the mystery, for all its terror, is also irresistible. It calls to you with a voice that is older than language, deeper than thought, more fundamental than fear. It is the voice of the universe itself, whispering secrets you cannot quite hear, showing you wonders you cannot quite see, inviting you to step forward into the darkness and discover what lies beyond the edge of everything you know. So you step forward, not because you expect to find answers, but because the act of stepping forward is itself the only response that makes sense in the face of such overwhelming mystery. You step forward into the void, into the uncertainty, into the cosmic loneliness and the existential vertigo, carrying with you nothing but your questions and your refusal to stop asking them. And the universe, vast and strange and incomprehensible, watches in silence as you descend. The silence of the cosmos is not passive. You begin to understand this now, in a way that transcends the abstract language of physics and burrows into something more primal. The silence is not the absence of sound. Space has never carried sound, has never needed to. The silence is something more profound, the absence of response. You have been asking questions of the universe for centuries, building instruments of extraordinary delicacy and ambition, launching telescopes into orbit, burying detectors deep underground, colliding particles at energies that briefly recreate the conditions of the primordial cosmos. And the universe has offered you fragments, glimpses, partial answers wrapped in deeper ambiguities, but it has never answered you fully. It has never consented to being understood, and you are beginning to suspect that this is not a temporary condition of incomplete knowledge. You are beginning to suspect that the universe's silence is its nature. You think about the detectors first. For decades, physicists have been searching for dark matter particles with instruments of breathtaking sensitivity, vast tanks of ultra-pure liquid xenon buried miles underground, shielded from cosmic rays by mountains of rock, cooled to temperatures near absolute zero, capable of detecting the faintest recoil of a single atomic nucleus struck by a passing particle. These experiments have grown progressively more sensitive, ruling out larger and larger swaths of the parameter space where dark matter particles were predicted to exist, and they have found nothing, not a whisper, not a single confirmed detection. The particles that were supposed to be everywhere, that were supposed to constitute the majority of all matter in the universe, have remained invisible to every instrument designed to catch them. This silence from the detectors is not merely a negative result, it is a statement. Each failed detection eliminates theoretical candidates with increasing precision, narrowing the space of possibilities to regions that are either technically unreachable or theoretically uncomfortable. The most popular candidates, the WIMPs, the weakly interacting massive particles that emerge so naturally from supersymmetric extensions of the Standard Model, have been largely ruled out across the mass ranges where theory most confidently predicted them. Supersymmetry itself, that elegant theoretical framework that promised to unify the forces and explain the hierarchy of particle masses, has found no experimental support at the Large Hadron Collider, despite operating at energies sufficient to have produced supersymmetric particles if they existed in the predicted mass range. Two of the most theoretically compelling ideas in modern physics, WIMP dark matter and supersymmetry, have both been confronted with silence where evidence should have been. And the silence echoes. You trace its reverberations through the history of attempts to detect and understand the invisible scaffolding of the cosmos. Axions, another dark matter candidate, remain undetected despite increasingly sensitive microwave cavity experiments. Sterile neutrinos, which once seemed promising after anomalous signals in certain X-ray observations, have proven inconsistent across datasets and remain elusive. Modified gravity theories propose to explain galactic rotation curves without invoking dark matter at all, struggle to simultaneously account for cosmological observations and galaxy cluster dynamics. Every path toward resolving the dark matter mystery leads either into silence or into deeper contradiction, but it gets worse. The silence is not limited to particle detectors or collider experiments. It extends into the realm of gravitational wave astronomy, where the detection of merging black holes and neutron stars has opened an extraordinary new window onto the universe. Gravitational wave observations have confirmed general relativity with stunning precision in the strong field regime, near compact objects where gravity is ferociously intense, but they have also revealed anomalies. Certain detected events show properties, mass ratios, spin configurations, population statistics that do not fit neatly into the scenarios predicted by stellar evolution theory. Some black hole mergers involve objects in mass ranges that theory suggests should not exist, the so-called pair instability mass gap, where stellar collapse should not produce black holes. Yet they appear in the data, solid and undeniable, carrying with them the implication that black hole formation may involve pathways or conditions not accounted for in current models. You feel the pattern consolidating around you. Every frontier of observation, optical, infrared, radio, X-ray, gravitational wave, is producing data that pushes against the edges of the standard framework. Each new instrument, each new detection method, each new window onto the cosmos reveals not confirmation of the expected, but variation on the theme of anomaly. The universe is consistent in only one way. It consistently refuses to behave exactly as predicted. This consistency of inconsistency has a name in the philosophy of science. It is called underdetermination, the condition in which multiple competing theories are equally capable of explaining the available data, making it impossible to definitively choose between them on empirical grounds alone. You are in a cosmological landscape of radical underdetermination, where the observations can be fit by the standard model with modifications, or by alternative dark matter models, or by modified gravity, or by early dark energy, or by varying constants, or by some combination of all of these, and where no single crucial experiment has yet delivered the verdict that would eliminate all but one. In this landscape, theory multiplies, models proliferate, and the risk grows that cosmology is generating not knowledge, but an expanding library of unfalsified possibilities, each consistent with the data and each contradicting the others. You pause to look at the sky again, not as a physicist, not as a theorist, but simply as a conscious being on a small planet orbiting an unremarkable star in a galaxy. That itself is one of perhaps 2 trillion galaxies in the observable universe. From this perspective, the sheer scale of what you are attempting to comprehend is staggering. 2 trillion galaxies, each containing hundreds of billions of stars, each star potentially hosting planets, each planet potentially hosting forms of complexity you cannot imagine. And all of this organized into a cosmic web of filaments and voids stretching across billions of light years, governed by forces and substances that remain largely mysterious, evolving according to a timeline that is now in dispute, operating under laws that may not be universal or constant. And you're trying to understand all of this from a single vantage point, on a single planet, with instruments that have existed for a handful of decades, using a brain that evolved over millions of years to navigate the savannah, to track prey and avoid predators, to build social relationships and solve immediate practical problems. The extraordinary thing is not that cosmology has failed to answer every question. The extraordinary thing is that it has answered any questions at all, that a creature so small, so limited, so recently arrived, has managed to map the cosmic web, measure the age of the universe, detect the faint thermal echo of the Big Bang, and discover the accelerating expansion of space. The human mind's reach is genuinely astonishing, but its reach has limits, and you are approaching them. Those limits manifest not just in the gaps in knowledge, but in the structure of the questions themselves. The deepest questions in cosmology: why does the universe exist at all? Why does it have the specific laws and constants it does? What happened before the Big Bang or outside the observable universe? What is the ultimate nature of dark matter and dark energy? Are questions that may not be answerable within the framework of science as currently practiced. They may require conceptual revolutions so radical that they cannot be imagined from within the current paradigm, or they may be questions that simply have no answers, questions that probe the boundary of the explicable and find only silence on the other side. The philosopher Ludwig Wittgenstein once wrote that whereof one cannot speak, thereof one must be silent. But cosmology cannot be silent. The questions are too urgent, too fundamental, too deeply intertwined with the question of what and where and when you are. So you continue to speak, even in the face of the universe's silence, even knowing that your words may be approximations at best, distortions at worst, and that the truth, if truth is even the right word, may be permanently beyond articulation. You return to the ancient galaxies, those impossible structures glowing at the edge of time. They have not moved, of course. They are frozen in the data, their light captured and analyzed and catalogued. But your understanding of what they represent has shifted profoundly over the course of this descent. They are no longer simply scientific puzzles, objects that challenge a model and demand a revised calculation. They have become something more personal, more existentially weighted. They are evidence that the universe has a past you cannot fully access, that it operated under conditions you cannot fully reconstruct, that it produced structures you cannot fully explain. They are windows not just into the early cosmos, but into the limits of your ability to know the cosmos. And what makes them genuinely haunting is not their size, or their brightness, or their impossible age. What makes them haunting is the implication of their existence, that between the universe that was and the universe that is, something fundamental changed, not just the temperature, not just the density, not just the distribution of matter, but perhaps the rules themselves. The transition from the early universe to the late universe may not be a smooth evolution, but a phase transition, a qualitative change in the nature of reality, comparable to the way water changes not just in temperature, but in structure when it freezes. The early universe may have been not just hotter and denser, but categorically different, a regime of physics that has no analog in the present cosmos and cannot be extrapolated from it with confidence. This idea, that the universe may have undergone phase transitions in its fundamental laws or constants, is not entirely without theoretical basis. In the landscape of string theory and quantum field theory, the vacuum state of the universe, the configuration of fundamental fields that determines the effective laws of physics, is not necessarily unique or permanent. It can exist in multiple metastable configurations, separated by energy barriers of varying heights, and it can tunnel between them through quantum processes. If the early universe was in a different vacuum state, it would have had different effective laws, different particle masses, different force strengths, a genuinely different physics that would have driven a different pattern of structure formation. And this is where the disturbing realization crystallizes with full force. If the universe has already undergone one or more vacuum phase transitions, if the physics you observe today is not the original physics but a descended, cooled, settled version of something more exotic, then you are not studying the fundamental laws of reality. You are studying the local, time-specific, contingent laws of this particular vacuum state, in this particular epoch, on this particular branch of cosmic history. The laws are not universal in the deepest sense. They are historical, the outcome of a sequence of transitions whose original starting point you cannot access, and whose future endpoint you cannot predict. Worse still, if the current vacuum state is metastable, if it is not the lowest possible energy configuration but merely a local minimum in the energy landscape, then it is subject to decay. At some point, at some location in space, a quantum fluctuation could nucleate a bubble of lower energy vacuum, and that bubble would expand outward at the speed of light, converting the universe inside it to a new set of physical laws. Everything within the expanding bubble, every galaxy, every star, every atom, every particle, would be annihilated or fundamentally altered as the new vacuum swept through. You would not know it was coming. There would be no warning, no signal, because the bubble travels at the speed of light and information cannot travel faster. One moment you exist, embedded in the physics of the current vacuum, and the next moment, nothing, or something so different from anything you know that the word something no longer applies. This is not science fiction. This is a genuine theoretical possibility, grounded in the mathematics of quantum field theory, supported by the measurement of the Higgs boson mass, which places the electroweak vacuum uncomfortably close to the boundary between stability and metastability. The universe you inhabit may be stable, it may be metastable, it may even have already begun its decay somewhere in the unreachable depths of space, a bubble of alien physics already expanding toward you at the speed of light, close enough that its light has not yet reached you to warn you of its arrival. The silence again, always the silence. You feel something shift in the emotional register of this journey at this point. The discoveries you have been processing, the impossible galaxies, the anomalous structures, the inconsistent constants, the failing dark matter models, the trembling of dark energy, have all been intellectually destabilizing, but they have been, at some level, abstract. Problems in a model, tensions in data, They have not felt immediately, personally threatening. The vacuum decay possibility changes that. It brings the cosmic strangeness home, makes it intimate, makes it visceral. The same universe that produced you, that created the conditions for matter and life and consciousness and curiosity, may be inherently impermanent at the deepest level, not just dying slowly through entropy, not just fading over trillions of years into heat death, but potentially capable of sudden, total, unannounced obliteration. The scale of that possibility is so enormous, so absolute, that it resists comprehension, and yet you must try to comprehend it. Not because comprehension offers comfort, it does not, but because the act of facing it honestly, of refusing to look away from what the evidence suggests, is itself a form of integrity. The universe is not obligated to be hospitable to your existence or comprehensible to your mind. It simply is what it is, operating according to whatever principles govern it, indifferent to your presence or your preferences. The most honest response you can offer is to look at it clearly, to acknowledge what it shows you, and to sit with the discomfort of what that implies. The implications multiply as you sit with them. If the vacuum is metastable, if phase transitions are possible, if the laws are historical and contingent, then the entire enterprise of cosmology takes on a different character. You are not uncovering eternal truths about the nature of reality. You are documenting the properties of one transient configuration of a reality that may be far vaster, stranger, and more variable than you can observe. The universe beyond your cosmic horizon, the regions from which light has not yet had time to reach you, the realms beyond the expanding sphere of your observational access, may be radically different from what you see. Different vacuum states, different laws, different histories, and there is no way to know. The cosmic horizon, once an exciting boundary that marked the edge of the known and promised more beyond it, now feels like a wall. Not a wall you can eventually break through, but a permanent barrier, a fundamental limit imposed by the finite speed of light and the accelerating expansion of space. As the universe expands, more and more of it recedes beyond your horizon, lost to you forever. Galaxies that are currently visible will eventually redshift beyond detectability, their light stretched to infinite wavelength by the expansion of space. The cosmic web will grow dimmer, the observable universe emptier, the darkness more complete. You are living in a privileged epoch, cosmologically speaking, a time when enough of the universe remains visible to reconstruct its history and glimpse its structure. In the far future, that reconstruction will become impossible. The evidence will be gone, erased by expansion, and the universe will appear to consist of nothing but your local group of galaxies, surrounded by infinite darkness. This prospect of ultimate cosmic isolation, the long, slow erasure of everything beyond your immediate neighborhood, is in some ways more disturbing than the possibility of sudden vacuum decay, because it happens gradually, inexorably, without drama. The universe does not end. It continues, expanding and cooling and darkening, but the connections that give it meaning, the threads of light that link distant galaxies, the photons that carry information across billions of light years, the cosmic web that reveals the large-scale structure of existence, all of these dissolve one by one into the growing silence of accelerating expansion. You find yourself thinking about entropy again, that fundamental tendency toward disorder and equilibrium. Entropy is the reason heat flows from hot to cold, the reason structures decay, the reason time has a direction. And in the far future of the universe, entropy wins completely. All energy gradients dissipate, all temperature differences smooth out, all structure, every galaxy, every star, every atom, eventually dissolves into a uniform sea of maximum entropy radiation. This is the heat death, the final state of the cosmos, the ultimate consequence of the second law of thermodynamics applied to the universe as a whole. It is not a dramatic ending. It is not a collapse or an explosion. It is a fading, a settling, a final and absolute stillness. But the heat death is so far in the future, so many orders of magnitude beyond the current age of the universe, that it feels abstract, disconnected from anything immediate or personal. What is not abstract is the direction of travel. The universe is moving toward heat death right now, at every moment, in every process. Every star that burns is converting ordered nuclear energy into dispersed thermal radiation, increasing entropy, moving the cosmos one small step further toward its final equilibrium. Every black hole that evaporates, a process that takes longer than the current age of the universe raised to enormous powers, releases its stored mass energy as Hawking radiation, further equilibrating the cosmos. The arrow of time points unambiguously toward dissolution, and you are embedded in that arrow, carried along by it, unable to reverse it or escape it. And now you see the full architecture of what you have been descending toward. It is not just a collection of anomalies. It is a vision of a universe that is stranger, more fragile, more isolated, more temporary, and more fundamentally unknowable than you ever imagined. A universe that began under conditions you cannot reconstruct, that evolved under laws you cannot be certain are stable, that is expanding toward a future you cannot stop, that may be one of countless domains in a larger reality you cannot access, and that will eventually dissolve into a silence so complete that no memory of its complexity will survive. You feel the weight of that vision settling into you. Not as despair exactly. Despair requires the expectation of something better, a standard against which the present falls short. This is something different. It is a form of awe that has crossed into dread, a recognition so vast that it compresses you, makes you feel the smallness of your existence, not just spatially but temporally and epistemologically. You are a brief arrangement of matter in a universe that did not intend you, cannot comprehend you, and will outlast you by incomprehensible spans of time, during which every trace of your existence will be erased and forgotten. And yet the galaxies still glow, the ancient light still travels, the questions still form in your mind, insistent and irreducible, demanding engagement even when engagement offers no final answers. This too is part of the picture, the improbable fact of consciousness in a cosmos trending toward unconsciousness, the existence of an observer in a universe that does not require one. You are here, looking at all of this, feeling the weight of it, and that fact is as mysterious as any galaxy or void or unexplained alignment, perhaps more so, because the deepest mystery may not be the ancient galaxies or the dark forces or the trembling constants. The deepest mystery may be the fact that any of this is being witnessed at all, that the universe, in producing you, produced something capable of asking why it exists, and then failed to provide an answer. That gap between the question and the silence that answers it may be the most honest portrait of the cosmos you will ever see. That gap between question and silence is where you now choose to live, not because it is comfortable, not because it offers shelter or warmth, but because it is the most honest address in the universe. Every civilization that has ever looked upward has tried to fill that gap with something: gods, myths, mathematical structures, inflationary cosmologies, string theory landscapes. Each filling has been an act of creative courage, an insistence that the silence must contain something, that the question must have an answer, even if the answer requires inventing an entirely new language to express it. You respect that insistence. You share it. But you are no longer willing to mistake the filling for the truth. There is a particular kind of intellectual honesty that feels almost like grief. It is the honesty of releasing certainties you did not know you were holding until they were gone. You thought you were approaching the universe as a skeptic, as a rigorous examiner of evidence, unencumbered by dogma, but the descent through these anomalies has shown you how many assumptions were quietly embedded in your baseline understanding, how many certainties masqueraded as axioms, how many stories dressed themselves as facts. The universe's age is certain until the Hubble tension. The laws are universal until the fine structure constant hints otherwise. Dark matter is real until every detector returns silence. Structure forms gradually until the Webb telescope shows you galaxies that were ancient when the universe was an infant. Each certainty released leaves behind not emptiness but something more disturbing, the awareness that you do not know what you do not know. That awareness has a technical name in epistemology: unknown unknowns, a concept that sounds bureaucratic but cuts to the heart of the deepest problem in science and in human thought generally. You can search for what you know is missing. You can design experiments to test specific hypotheses, build detectors for predicted particles, look for the signatures of expected phenomena, but you cannot search for what you do not know is missing. You cannot design an experiment for a phenomenon you have not imagined. You cannot look for a signature whose shape you cannot conceive. The unknown unknowns in cosmology may be vast, may be fundamental, may be the very things that would resolve every tension and explain every anomaly, and you are by definition unable to approach them directly. You can only hope that they will reveal themselves through anomalies, through the cracks in your models, through the universe's persistent refusal to behave as expected, which is precisely what is happening, and which means that the anomalies, for all their disorienting implications, are your most precious data. You sit with that reversal for a moment. The failures of the standard model, the tensions and discrepancies, the impossible galaxies and the silent detectors and the inconsistent constants, these are not causes for despair. They are invitations. They are the universe pushing back against your framework, insisting on its own complexity, refusing to be reduced to a story that fits neatly within the boundaries of human imagination. Every anomaly is a crack in the wall through which something new might enter. And the history of science is, at its deepest level, a history of those cracks, moments when the data refused to cooperate and the resulting discomfort forced a revolution in understanding that nobody could have predicted from within the old framework. Copernicus saw a crack and found that the Earth was not the center. Newton saw a crack and found that gravity was a universal force. Einstein saw a crack and found that space and time were not absolute. Planck saw a crack and found that energy was quantized. Each of these discoveries transformed not just the content of science but the shape of the possible, expanding the universe of ideas that could be conceived, the range of questions that could be asked, the depth to which reality could be probed. You are living through another such moment. The cracks are everywhere. The walls are trembling. Something new is trying to come through. But here is what the history of those revolutions also teaches. They were never comfortable. They were never welcomed with open arms by the scientific community of their day. They were resisted, disputed, minimized, reinterpreted, and argued against with great vigor and genuine intellectual effort. Not because scientists are uniquely stubborn or closed-minded. They are human with the same cognitive biases and institutional pressures as everyone else, but because the old frameworks were not simply wrong. They were approximately right, useful, powerful, confirmed by vast quantities of evidence. Abandoning them required not just new evidence but new courage, a willingness to embrace a period of genuine uncertainty in which the old framework had been abandoned and the new one had not yet solidified. That period, the liminal space between paradigms, is where cosmology now lives. The standard model is not wrong in the way that a calculation error is wrong. It is wrong in the way that Newtonian mechanics was wrong when confronted with the precession of Mercury's perihelion. Mostly right, extraordinarily useful, confirmed across an enormous range of conditions, but harboring within its foundations a crack that pointed toward something deeper. The Lambda CDM model has built the most successful large-scale map of the universe ever constructed. Its predictions have been confirmed across decades of observation, but it is cracking, and the cracks are not superficial. The question that haunts the liminal space is not whether the standard model needs revision. It does, clearly, demonstrably. The question is, what kind of revision is required? Is it a minor adjustment, a tweak to the parameters, the addition of a new component that preserves the essential structure? Or is it something more radical, a conceptual overhaul that replaces not just specific predictions, but the foundational assumptions on which all predictions rest? The history of science contains both kinds of revisions, and there is no reliable way to tell in advance which kind is needed. You do not know from inside the crisis whether you are facing a Newtonian correction or a relativistic revolution. What you can do is look more carefully, think more deeply, question more rigorously. You can push the instruments further, build larger telescopes, design more sensitive detectors, develop more sophisticated theoretical frameworks. You can look at the data without the lens of expectation, resisting the temptation to fit anomalies into familiar categories and instead allowing them to suggest new ones. You can cultivate the particular kind of intellectual humility that holds two contradictory things simultaneously: the conviction that science is the most powerful tool ever devised for understanding reality, and the recognition that science, as currently practiced, may be operating within conceptual limitations that it cannot see from the inside. And you can look outward, always outward, because the universe, for all its silence, is not withholding information out of hostility or indifference. It simply is, and every part of what it is carries information, encoded in light and gravity and the motion of matter, waiting to be read by instruments sensitive enough and minds flexible enough to receive it. The Webb telescope is still observing. New gravitational wave detectors are being designed with sensitivities that dwarf the current generation. Pulsar timing arrays are beginning to detect the faint background hum of gravitational waves from supermassive black hole mergers across cosmic time. The square-kilometer array will map the universe in radio waves with a resolution and depth that will transform cosmology the way the first optical telescopes transformed astronomy. The data is coming. More data than any previous generation has had, more precise, more detailed, covering wider ranges of wavelength and timescale and spatial scale. And the data will be strange. You can almost guarantee that, because every time humanity has built a significantly more powerful instrument, the universe has responded by presenting phenomena that nobody predicted and everyone struggled to explain. The first radio surveys revealed quasars, objects of unimaginable luminosity that defied every existing model of energy generation. The first X-ray surveys revealed neutron stars and black holes, objects so extreme that their existence had been doubted even after their prediction. The first gravitational wave detections revealed black hole mergers in mass ranges that pushed against theoretical expectations. Every new window brings new wonders, and every new wonder brings new disorientation, and every new disorientation, eventually, brings new understanding. Eventually. That word carries enormous weight when you consider the scale of the mystery. Some of these questions may be answered within your lifetime, or within the next century. Others may require generations, may require conceptual tools not yet invented, may require a form of mathematics that does not yet exist. Some may require a future in which artificial intelligence systems assist in the exploration of theoretical space, with a thoroughness and speed no human mind can achieve, mapping the landscape of possible theories and identifying the ones consistent with all available data in ways that would take human cosmologists centuries to accomplish manually. Some may require observations not just from Earth or from low orbit, but from instruments deployed across the solar system, using the distances between planets as a baseline for measurements of unprecedented precision, or even, in the deepest future, from instruments placed in other star systems, observing the cosmos from vantage points that would reveal its large-scale structure in ways impossible from a single location. But some questions may never be answered, not because science will give up, but because the structure of reality may be such that certain answers are permanently inaccessible. The regions beyond the cosmic horizon will never be directly observable. The physics of the pre-inflationary universe may leave no detectable imprint on anything you can measure. The nature of the initial conditions of the Big Bang may be underdetermined by any conceivable observation, because the information that would specify those conditions has been washed out by inflation or lost behind event horizons. The question of why the universe exists rather than nothing, the deepest question, the one that sits beneath all others, may be not just currently unanswerable but permanently so. A question that points to something that lies outside the domain of scientific inquiry entirely. This is not a defeat, it is a boundary, and boundaries are informative.
The existence of questions that cannot be answered within a given framework tells you something important about the limits of that framework, and therefore about the shape of what lies beyond it. The boundary of science is not the boundary of reality. It is the boundary of one particular, extraordinarily powerful way of engaging with reality.
Beyond that boundary, other ways of engaging exist, philosophical, experiential, contemplative, and while they do not produce the kind of precise, testable knowledge that science produces, they are not therefore worthless. They are responses to the same universe, attempts to make meaning from the same raw material of experience and observation, and they may reach aspects of reality that the scientific method, by design, does not address. You feel the landscape of the question shifting under you as you absorb this. You began this journey in the domain of physics and astronomy, equipped with data and theory, following the chain of evidence wherever it led. But the chain has brought you here, to the edge of the scientifically articulable, to the boundary where empirical inquiry shades into something harder to name. The universe is pointing at something it cannot tell you directly, the way a finger pointing at the moon is not the moon. The anomalies, the tensions, the failures of the standard model, they are all fingers pointing at something that may require a new kind of seeing, a new kind of thinking, a cognitive revolution as profound as the one that produced science itself. You think about consciousness again, not sentimentally, not as a retreat from the hard problems of physics, but because consciousness is itself one of the universe's most anomalous products. In a cosmos trending toward disorder, toward equilibrium, toward the erasure of structure and complexity, consciousness represents something almost paradoxical, a process that generates meaning, that imposes narrative, that experiences time as a flow rather than a static four-dimensional block, that feels the weight of the past and the pull of the future. These properties of conscious experience are not explained by physics. They are not predicted by any current theory. The hard problem of consciousness, the question of why there is subjective experience at all, why there is something it is like to be you rather than nothing, is as deep and as resistant to resolution as any question in cosmology. And there is a possibility, not yet mature enough to be called a theory but persistent enough to be called a suspicion, that consciousness and cosmos may be more intimately connected than the standard picture of mind as a byproduct of brain chemistry suggests, not in a mystical sense, not in a way that abandons scientific rigor, but in the sense that the existence of observers may be a fundamental feature of the universe rather than an accidental one. The anthropic principle, in its various forms, attempts to grapple with this. The observation that the universe appears fine-tuned for the emergence of complexity in life, that the fundamental constants sit in a narrow range where chemistry, stars, and eventually conscious beings are possible. This fine-tuning may be explained by the multiverse, by anthropic selection from a vast ensemble of different universes, or it may be pointing at something else entirely, a connection between the existence of observers and the structure of reality that no current framework adequately captures. John Wheeler, one of the architects of modern quantum mechanics and general relativity, spent the latter part of his career thinking about what he called the participatory universe, the idea that the act of observation is not merely a passive recording of pre-existing facts but an active participation in the construction of physical reality. Quantum mechanics, in its standard interpretation, gives some support to this idea. The measurement process plays a fundamental role in determining outcomes, and the boundary between observer and observed is far less clear in quantum theory than in classical physics. Wheeler pushed this further, speculating that consciousness might be not just a product of the universe but a constitutive element of it, that the universe could not be well defined without observers to collapse its quantum possibilities into actualities. These ideas remain deeply controversial and far from established, but they gesture toward a possibility that the descent through cosmic anomalies has made feel less remote. The possibility that the universe is not a thing that exists independently of everything that happens within it, but is in some sense a process, a becoming, a continuous act of self-definition in which the emergence of consciousness plays a role that physics has not yet been able to articulate. If this is even partially correct, then the silence you have been feeling, the universe's failure to respond to your questions, is not the silence of indifference. It is the silence of something that does not stand apart from you far enough to answer. Something so fundamentally entangled with the act of observation that the distinction between the questioner and the questioned begins to dissolve. You do not know if this is true. You cannot know with any current evidence whether the universe is participatory in this deep sense or whether consciousness is simply what it appears to be on the surface, an emergent phenomenon, a local and temporary complexity arising from the interactions of matter and energy, remarkable but not cosmically constitutive. But you notice that the question feels different now than it did at the beginning of this descent. It feels connected to everything else you have been examining, to the anomalies, to the inconsistencies, to the silence of the detectors and the trembling of the constants, in a way that suggests it is not a separate question but perhaps the same question asked from a different direction. Because ultimately, the deepest mystery of the cosmos is not any specific anomaly or tension. It is the mystery of self-reference. The fact that the universe contains beings who study the universe, that matter has organized itself into forms capable of asking why matter exists, that the cosmos has produced within itself something capable of wondering at the cosmos. This is the most anomalous thing of all, more anomalous than the ancient galaxies, more disorienting than the Hubble tension, more vertiginous than the possibility of vacuum decay. The universe has made eyes with which to see itself, and what those eyes see is a universe they cannot fully comprehend. And you, here, now, reading these words, following this descent through the deepest strangeness of the cosmos, you are one of those eyes. You are the universe looking at itself, feeling the vertigo of its own incomprehensibility, holding the weight of questions that may have no answers. You are not separate from the mystery. You are part of it, embedded in it, constituted by it. The hydrogen in your body was forged in the Big Bang. The heavier elements in your bones and blood were forged in stellar cores and in the cataclysm of supernovae. You are made of ancient starlight, shaped by the same gravitational processes that built the cosmic web, existing in the same epoch of cosmic history that produced the impossible galaxies and the dark forces and the trembling constants. You are not an observer of the universe. You are an expression of it, a local, temporary, self-aware knot in the fabric of space and time, capable of asking questions that the fabric itself cannot answer. And that incapacity, the universe's inability to explain itself to itself through you, is not a failure. It is the most honest thing the cosmos has ever produced. It is the universe's own acknowledgement, expressed through your bewilderment, that it is stranger than it knows. The ancient galaxies still glow at the edge of time. The voids still yawn between the filaments. The dark matter still moves unseen and silent through the cosmic web. The dark energy still pushes the universe outward, accelerating the expansion, drawing the galaxies apart, widening the silence between them. The constants may be shifting or they may be stable, and the instruments are watching, always watching, waiting for the data that will tell you which. The The crack between the question and the answer is still there, wide and dark and full of implication, and you are still here, falling into it, eyes open. The stillness is profound, yet it hums with latent energy. In that quiet, you detect a tension, not of noise or movement, but of possibility waiting to be realized. The universe, vast and intricate, is coiled like a spring, balanced on the knife's edge between what can be known and what remains forever obscure. This tension is where curiosity ignites, where the drive to push further, to pry open the cosmic mystery, takes hold. It is a subtle force, intangible but inexorable, pulling you forward into depths that shimmer with the luminous glow of the not yet understood. Yet for all the scientific tools and mathematical frameworks assembled, there is an irreducible humility that seeps in here, acknowledging the chasm between the human mind and the cosmos's boundless complexity. This humility is not defeat, but a recognition of scale and perspective. Compared to the universe's vastness, your grasp is a flickering candle flame, brave but fragile. This understanding grounds you, tempering the desire to claim certainty and opening space instead for wonder, curiosity, and the patient work of exploration. You wonder how many civilizations across the cosmic expanse have looked up at their skies and glimpsed this very same paradox, an urge to comprehend paired with the vast unknowability pressing against that urge. Are they, somewhere in the infinite reaches, confronting their own forms of cosmic loneliness? Are their own questions shaped by different histories, different laws, different languages, yet still the same fundamental human thirst for meaning? This thought weaves you into a larger fabric, an interconnectedness that transcends individual isolation. You are not alone in your questioning. You share an ineffable bond with every seeker gazing into the unknown. That shared pursuit imbues the passage of knowledge with an almost sacred quality. The discoveries of mathematics, physics, and astronomy become a collective symphony, notes contributed across generations and worlds, a slow accretion edging ever closer to clarity, if not finality. Each anomaly, each unexpected observation, acts as a discordant chord that unsettles but also enriches the melody. The cosmos is composing its own story, and you, observer, participant, enigma, are part of the orchestra, playing your uncertain tune. And now, voice lowered, you face the question that silently undergirds all others: what to do with this vast unknowability, how to live with the uneasy awareness that the universe is far stranger and less predictable than the neat, comforting models taught to any student. It is a personal crossroads common to all explorers, whether astronomers or poets, philosophers or poets, faced with the paradox of a universe that invites question but resists answer. One path leads to despair and nihilism, the temptation to retreat behind the veil of ignorance, to insist that if the universe cannot be pinned down and classified, it may as well be meaningless. But that path is narrow and cold, cutting off the pulse of curiosity and wonder that makes engagement possible. You find it harder to follow, yet you do not dismiss its appeal. In moments of profound bewilderment, the simplicity of giving up is seductive. Another path, more difficult yet radiant, embraces uncertainty as a kind of creativity. It is the path of openness, to paradox, to ambiguity, to complexity without reduction. It is a rebellion against the compulsion for final answers and neat narratives, a willingness to sit with attention itself, to allow questions to live in a state of graceful suspension. That path is a radical affirmation of wonder, an acknowledgement that the unknown is not a void but a fertile space for imagination and discovery. You recognize this is where true courage lies, not in conquering mystery, but in embracing it with grace, to act, to explore, to push boundaries, knowing that certainty may never come, knowing that the most profound truths may always shimmer just beyond reach. This courage does not dissolve the existential vertigo, but steadies the inquiring mind, allowing you to lean into the vast silence without collapsing into despair. The telescopes will continue to gather rays of ancient light. The gravitational waves will ripple ever faintly through your detectors. The constants may shift or hold steady, and the dark matter will remain elusive or finally yield its secrets. Whatever unfolds, the act of looking, of asking, measuring, theorizing, challenging assumptions, will persist. It is an expression of a deeply human will to understand that defines your place in the cosmos as much as any equation or map. That will to understand is paradoxically also an acceptance of mystery. It is not an either-or, but a both-and. The universe offers riddles no model can fully capture and reveals patterns profound beyond reckoning. It is simultaneously knowable and unknowable, intimate and remote, ordered and chaotic. This duality is the cosmic dance, the rhythm to which all inquiry must attune itself. You feel a new calm, subtle but undeniable, growing within you. It is not the calm of answers discovered or certainties declared, but the calm of willingness, to explore without guarantee, to persist without promise, to wonder without the need to reduce the universe to human terms. This calm deepens the awe into something quieter yet more expansive, a presence that can hold paradox without breaking. The cosmic abyss, once terrifying in its silence, now reveals itself also as a vast cradle of possibility. It is the birthplace of stars and galaxies and perhaps of thought itself. It is the stage upon which the drama of existence unfolds, with you both audience and actor. Within the tension of unknowability lies the promise of discovery. Within the vertigo lies the spark of life. Perhaps the ancient galaxies, glowing faint across unimaginable distances in time, are not only beacons of cosmic history, but symbols of persistence, of complexity emerging from simplicity, of light emerging from darkness. They remind you that even in the vastness and apparent indifference of the cosmos, pockets of order, pockets of meaning, emerge and endure. They are proof that the universe is not wholly silent but communicates, through patterns, through structures, through the delicate interplay of forces, if only you know how to listen. And listening is an act of humility, patience, and care. It requires not only instruments attuned to the faintest ray or gravitational whisper, but a mind and spirit open to surprise, to contradiction, to the failure of expectation. It requires an acceptance that the universe's story is not yours to finish, but yours to witness. The cosmic web, with its filaments and voids, its enigmatic dark matter and accelerating expansion, extends before you like an infinite labyrinth, complex, sprawling, and unfinished. You stand at its edge, an explorer uncertain of the path ahead but unwilling to turn back. Each step forward is both question and answer, both descent into the unknown and affirmation of existence. The universe's silence is not emptiness. It is a vast, unspoken invitation, an encouragement to find meaning not despite uncertainty but through it, to become meaning makers in a cosmos that does not deliver easy truths but challenges you to create understanding through exploration, connection, and wonder. And so you continue, not because the mysteries are solved, but because the act of seeking is itself a testament to existence. The cosmos may never yield its full secrets to you, not in this lifetime or the next, but every glimmer of insight, every unanswered question, every impossible galaxy is a spark in the darkness, illuminating the pathway ahead. You gaze upward once more. The ancient light travels still, the voids beckon, the constants may tremble, the dark matter remains elusive. The universe waits, vast and profound, silent yet speaking through each new anomaly, each new tension, each new question born from wonder. And you, part of the cosmos you seek to understand, stand firm in the silent song of the universe, ready to listen, to question, and to marvel. But the universe does not care that you are ready. That is the thing you keep almost forgetting, keep almost softening into something more bearable. The cosmos is not waiting for you. It is not holding space for your wonder or your courage or your willingness to persist. It was here for 9 billion years before the Earth formed, and it will continue for spans of time so incomprehensible that the entirety of human civilization, every war, every poem, every equation, every telescope ever built, will represent a duration so brief it does not register as a rounding error in the cosmic ledger. The universe's silence is not an invitation. It was never an invitation. It is simply what exists when no one is speaking and no one is required to. You need to sit with that distinction, the difference between a silence that invites and a silence that simply is. Because the temptation to read invitation into indifference is one of the oldest and most persistent errors of the human mind. It is the cognitive reflex that finds faces in clouds, narrative in random events, purpose in coincidence. It is the same reflex that populated the night sky with gods and heroes, that heard messages in thunder and meaning in the alignment of stars. You have inherited that reflex from 100,000 years of ancestors for whom pattern recognition was survival, for whom the cost of a false positive, seeing a predator that was not there, was far lower than the cost of a false negative, missing one that was. You are wired to find meaning. The universe is not wired to provide it. And this is where the unsettling truth consolidates, where it stops being a philosophical abstraction and becomes something you feel in the structure of your own cognition. Every framework you have for understanding the cosmos, every equation, every model, every conceptual metaphor, was built by a brain shaped by evolution, for an entirely different set of challenges. The savannah, not the void. Social relationships, not quantum fields. Immediate causality, not probabilistic superposition. You are using a tool that was not designed for this job. And the remarkable thing is not that the tool sometimes fails. The remarkable thing is that it has worked as well as it has. That the monkey-descended mind has reached as far into cosmic structure as it has, and that the reaching has produced genuine knowledge rather than mere story. But genuine knowledge has limits, and those limits are not merely technical. They are not simply a matter of needing better instruments or more data or more powerful computers. Some of the limits are architectural, built into the structure of the mind itself. Human intuition fails at scales both very large and very small. You cannot viscerally grasp the curvature of space-time or the superposition of quantum states. You can manipulate the mathematics that describes these things, but you cannot feel them in the way you feel the weight of a stone or the warmth of sunlight. The mathematics works, it predicts, it describes, it guides the construction of instruments that confirm its predictions, but the understanding it produces is of a particular, restricted kind. It is a map that captures the territory's topology without conveying what it feels like to stand in it. And the territory may have regions the map cannot represent at all, not regions that are merely difficult to map, but regions that are constitutively unmappable by any cartography available to you. The breakdown of spacetime at the Planck scale, where quantum effects and gravitational effects become equally important, and the smooth, continuous structure of general relativity dissolves into something for which no adequate theory yet exists. The nature of the initial singularity, if it was a singularity and not something else entirely, a bounce from a prior contraction, a nucleation from a quantum vacuum, a collision between higher dimensional membranes. The question of what, if anything, preceded or surrounded the Big Bang, in a context where the word preceded may not even be meaningful, where the very concept of before may break down along with the space-time it presupposes. These are not gaps in the map. They are edges where the map ends and the territory continues, and you have no way of knowing what the territory looks like beyond those edges, because every instrument you possess exists inside the map. The Large Hadron Collider exists inside the map. The James Webb Space Telescope exists inside the map. Every gravitational wave detector, every pulsar timing array, every cosmic ray observatory exists inside the map. They are extraordinary instruments, probing the map's finest details with precision that would have seemed miraculous a century ago, but they cannot reach outside it. They are embedded in the very space-time and physics they are trying to understand, using the very forces and particles whose nature is in question to investigate the forces and particles whose nature is in question. The circularity is not a flaw in the scientific method, it is a fundamental feature of the epistemic situation, the condition of being inside the system you are trying to describe. Gödel's incompleteness theorems cast a long shadow here, longer than is usually acknowledged. Gödel proved that within any sufficiently complex formal system, there exist true statements that cannot be proven within that system. The system cannot fully describe itself. To prove those statements, you need a larger system, but that larger system in turn has its own unprovable truths, requiring a yet larger system in an infinite regress. The universe may be, in a very deep sense, Gödelian. It may contain truths about itself that cannot be accessed from within it, that require a meta-perspective which, by definition, you cannot occupy, not because you have not tried hard enough, but because the attempt is structurally impossible for any observer embedded within the system being observed. You feel the walls of the situation closing in from every direction simultaneously, not in panic, but in a kind of slow, measured recognition. The instruments are limited, the mind is limited, the mathematics is limited, the observable universe is a finite sphere surrounded by regions you cannot see. The laws may be contingent and local, the vacuum may be unstable, the anomalies multiply, the silence of the detectors deepens, and beneath all of this, the most fundamental questions, why anything exists, what the universe ultimately is, whether the laws are necessary or accidental, whether consciousness is incidental or constitutive, remain untouched by all the extraordinary machinery of modern science, not because science has not tried, but because these questions may be asking for something that the scientific framework, however powerful, was never built to deliver. The history of the observable universe is approximately 13.8 billion years long, or so the current models say, with the caveat that those models are under stress. In that time, the universe has expanded from a state of extraordinary density and temperature to the vast, cold, dark, mostly empty space you observe today. In the process, it has produced hydrogen and helium, then stars, then heavier elements, then planetary systems, then chemistry, then life, then consciousness, then science, then cosmology. This sequence, this astonishing chain of emergent complexity, is one of the most remarkable things you know. It is not guaranteed by the laws of physics. It is not required by anything. It happened, and its happening produced you, and your existence is a consequence of every link in that chain being exactly as it was, not approximately, not nearly, but exactly. A slightly different baryon to photon ratio in the early universe, a slightly different value of the weak nuclear force, a slightly different initial density perturbation in the region that became the Milky Way. Any of these altered, and you are not here. The chain breaks somewhere. The complexity does not emerge. The universe ticks forward in darkness without anyone to notice. This is the fine-tuning problem in its most personal and unsettling form. Not as a philosophical puzzle about probabilities, but as a direct confrontation with the contingency of your own existence. You are here because the universe was calibrated, whether by chance or necessity or selection from a vast ensemble, to produce you. And that calibration is so precise, across so many independent parameters, that it does not feel like chance, even though chance is the most honest description available within the current framework. The alternatives, necessary laws, divine design, anthropic selection from a multiverse, all carry their own profound difficulties, their own questions that cannot be answered, their own silences that gape at the center of the explanation. The multiverse, if it exists, does not comfort, it amplifies. If there are infinitely many universes, each with different constants, then the emergence of life in this one is trivially explained. Of course, you find yourself in one that permits your existence, because you could not find yourself in one that does not. But this explanation, though logically valid, is existentially hollow. It does not tell you what the other universes are like. It does not tell you whether any of them contain conscious beings who are also looking up at their skies and feeling the same vertiginous bewilderment. It does not tell you whether the multiverse itself has a cause or a structure or a purpose. It simply displaces the mystery one level upward, from the question of why this universe has these laws to the question of why there is a multiverse that generates universes with varying laws. And that question is, if anything, deeper and less tractable than the one it was invoked to answer. You have now descended far enough that the layers beneath you are indistinguishable from each other. Every question opens into another question of equal depth. Every explanation requires an explanation. Every framework presupposes a meta-framework, and at no level, not in physics, not in mathematics, not in philosophy, not in any other mode of inquiry available to you, does the regress terminate in something self-evident, something that requires no further explanation, something that simply is and needs no justification. The universe does not come with a foundation. It appears to float, unsupported over an absence, not a void of space, not an emptiness of matter, but an absence of ultimate reason, a brute facticity that resists all demands for explanation. Some physicists and philosophers have argued that this should not disturb you, that the demand for a foundation, for an ultimate explanation, is itself a category error, a confusion between the questions that are meaningful to ask and the questions that merely feel meaningful. They argue that why is there something rather than nothing is not a genuine question but a linguistic artifact, a sentence that has grammatical form but no real referent, because nothing is not a state the universe could coherently have been in, because the very concept of nothing, of absolute absence, may be self-contradictory, may smuggle in something in the very act of being conceived. This argument is clever, and it may be correct, but it does not dissolve the feeling. It does not eliminate the vertigo. It does not make the silence feel less absolute, because the silence is not just philosophical, it is physical. It is in the data, the impossible galaxies formed without explanation. The dark matter refused every detection. The Hubble tension persisted across every systematic check. The constants hinted at variation across cosmic distances. The CMB carried alignments that should not be there. The gravitational wave catalog filled with mergers that pushed against theoretical predictions. Each silence, each anomaly, each tension, they are not philosophical abstractions. They are measurements, numbers, photon counts and redshifts and temperature maps and strain amplitudes. The universe has been producing anomalous data, and the data does not care about your philosophical equanimity. It simply sits there in the databases and the published papers and the conference proceedings, waiting for a framework adequate to contain it, and no such framework has yet appeared. The waiting may be long, longer than any individual human lifetime, longer than the current institutions of science can sustain without revision. The next paradigm, If there is one, if the anomalies are pointing toward a coherent new framework, rather than an irreducible chaos, may require decades or centuries to emerge. It may require generations of scientists who accept the anomalies as primary data, rather than embarrassing exceptions, who build their theories around the failures rather than the successes of the current model, who are willing to abandon not just specific predictions but the foundational assumptions that have shaped cosmology since Einstein. That kind of willingness is extraordinarily rare. It requires not just intellectual courage but institutional support, cultural permission, and a willingness to spend a career in a field where the foundation is explicitly uncertain and the destination is unknown. And even then, even if the paradigm shift comes, even if a new framework emerges that resolves the Hubble tension and explains the impossible galaxies and identifies dark matter and provides a coherent account of dark energy and reconciles gravity with quantum mechanics, even then the deepest questions will remain. The new framework will be more accurate, more comprehensive, more predictive than the current one. It will illuminate aspects of the cosmos that are currently in shadow, but it will also, inevitably, generate new anomalies, new tensions, new questions that it cannot answer, because that is what every paradigm shift has done. Not closed the mystery, but deepened it, revealed new layers of complexity beneath the ones it resolved, pushed the frontier of the unknown further but never eliminated it. The frontier cannot be eliminated. That is perhaps the most important thing the history of science teaches. Not that knowledge is impossible. It is not, and the achievements of the last few centuries are among the most extraordinary things the human mind has ever produced. But that knowledge is asymptotic. It approaches something, truth, reality, the structure of the cosmos without ever reaching it. Each step forward reveals more ground ahead. Each answer generates more questions than it resolves. The horizon recedes as you advance, not because you are failing, but because the territory is genuinely infinite and your instruments are genuinely finite, and no amount of technological progress or theoretical ingenuity can bridge a gap that is structural rather than technical. You have known this in some abstract sense for a long time, but the descent through the anomalies has made it concrete, has given it weight and texture and emotional substance. It is not an abstraction anymore. It is the specific silence of the dark matter detectors. It is the specific improbability of the ancient galaxies. It is the specific anxiety of the Hubble tension, persistent and unresolved through years of increasingly precise measurement. It is the specific chill of the metastable vacuum, that theoretical possibility of sudden and total obliteration carrying within it no warning and no mercy. These are not abstractions. They are the universe's way of making the frontier palpable, of demonstrating through data what philosophy can only assert through argument. And so you arrive, finally, at the place this descent has been carrying you toward from the beginning. Not an answer, not a resolution, not a moment of revelation in which the pieces click together and the universe reveals itself to be exactly as strange as it appeared, but ultimately coherent, ultimately comprehensible, ultimately on your side. That moment does not come. It was never coming. The universe is not on your side. It is not on anyone's side. It simply is. Vast, strange, partially accessible, fundamentally opaque, operating according to principles that may or may not be discoverable by the kind of mind that evolution happened to produce on this particular planet, in this particular epoch. What you arrive at is not comfort, but clarity. The clarity of seeing the situation as it actually is, without the softening lens of false hope or the distorting lens of despair. The situation is this: you exist, briefly and improbably, in a universe of extraordinary complexity and beauty and danger and indifference. The complexity is real. The cosmic web, the ancient galaxies, the gravitational waves, the quantum foam. The beauty is real, not as a property of the universe, which does not care about beauty, but as a property of your perception of it, which does. The danger is real, the metastable vacuum, the eventual heat death, the indifference of scale. And the indifference is real, perhaps the most real of all, the bedrock fact beneath every other fact, the thing that remains when everything else is questioned. The universe does not know you are here. It has never known. The photons from the ancient galaxies that fall on your detectors are not messages addressed to you. They are the residue of processes that occurred long before your planet existed, in galaxies that were already dead before your sun ignited, carrying information about a universe that was already ancient when the first cell divided in the primordial ocean. That information reached your instruments not because the universe directed it there, but because the geometry of space-time, operating according to laws that do not care about destinations, happened to allow a path between there and here, between then and now. You built the instruments. You pointed them at the sky. You analyzed the data and identified the anomalies and followed them down into this darkness. That entire process, the building, the pointing, the analyzing, the following, was yours. It emerged from the same universe, from the same matter and energy that constitute everything else, but it was not directed by the universe. It was generated by you, by the improbable complexity that the universe, through no intention, happened to produce. The meaning you find in the anomalies, the significance you attach to the silence, the vertigo you feel at the edge of the unknowable, none of that is in the data. It is in you. You brought it. You are the only thing in this entire account that contains anything resembling meaning, and you are temporary. The temporary nature of your meaning-making is the last anomaly, the one that underlies all the others. In a universe trending toward maximum entropy, toward the erasure of all structure and complexity, consciousness is an eddy, a local, temporary, improbable reversal of the general trend, a pocket of order that generates and sustains meaning for a brief interval before dissolving back into the equilibrium that surrounds it. Every thought you have, every question you ask, every moment of genuine understanding, these are acts of resistance against the thermodynamic current, brief upstream flickers in a river flowing permanently downward. They are real. They matter, within the context of their own brief duration, but the context is finite, and outside it, in the vast, cold dark of cosmic time, they do not echo. No civilization that has ever existed has left a permanent mark on the universe. The structures they built have dissolved or will dissolve. The signals they sent into space are dispersing, attenuating, redshifting toward indetectability. The modifications they made to their local environments are temporary perturbations in the surface of a planet that will itself be consumed by its expanding star in roughly 5 billion years. The universe will not remember. It does not have the capacity to remember. Memory requires structure, and the universe is systematically dismantling every structure it has ever produced. And yet here you are, at the end of this descent, still asking, still looking at the data, and feeling the weight of what it implies, still unwilling to close your eyes against the ancient light of impossible galaxies. The asking persists, not because it will accomplish anything in the cosmic ledger, not because the universe will respond, not because the anomalies will resolve themselves into a final, satisfying answer. The asking persists because you are the kind of thing that asks because consciousness, wherever it emerges, however briefly, carries within it an orientation toward understanding that cannot be switched off by the recognition of its own futility. You ask because you cannot not ask. And the universe, which created you without intending to and will erase you without noticing, does not find this ironic. It does not find anything. The irony is entirely yours. The ancient galaxies are still there. The James Webb Space Telescope is still collecting their light, still adding to the database of impossibilities, still generating papers that begin with phrases like anomalous morphology and unexpected stellar populations, and inconsistent with standard formation models. The Hubble tension is still unresolved, still sitting in the data like a splinter, still prompting workshops and reviews and increasingly desperate theoretical patches. The dark matter detectors are still running, still returning null results, still eliminating candidates with each passing year, still narrowing the space of possibilities toward regions that are either technically inaccessible or theoretically uninviting. The constants may be drifting. The vacuum may be unstable. The framework is cracking. None of this will stop. The data will continue to arrive. The anomalies will continue to accumulate. The framework will continue to strain under their collective weight. And eventually, not soon, perhaps not within any lifetime now living, but eventually, something will give. The framework will break, or it will transform, or a new one will emerge alongside it and gradually supersede it, the way general relativity gradually superseded Newtonian gravity, without invalidating it within its domain of applicability. The mystery will deepen before it clarifies, if it clarifies at all. The questions will multiply before they resolve, if they resolve at all. And the universe, throughout all of this, throughout the conferences and the papers and the new telescopes and the paradigm shifts and the generations of scientists who devote their lives to prying open its secrets, the universe will continue to do what it has always done. It will expand. It will cool. It will carry the ancient light across distances that make the word vast seem insufficient. It will allow dark matter to move, unseen, through its cosmic web. It will permit the dark energy to push the galaxies apart, widening the silences between them, drawing each island of light further from every other island of light, until the night sky empties, and the cosmic web dissolves, and the last stars burn out, and the last black holes evaporate, and the final, absolute equilibrium settles over everything that remains. There will be no one left to observe that final state. The observers are temporary. The observations are temporary. The meaning extracted from the observations is the most temporary thing of all. What persists is the universe itself, not as witness, not as narrator, not as participant in any drama, but as the simple, brute, unexplained fact of its own existence, carrying within it no message, no purpose, no acknowledgement of everything that briefly and improbably happened within it. The light from the ancient galaxies is still traveling. Some of it has not yet reached you. Some of it, from galaxies already beyond your cosmic horizon, will never reach you, will instead continue outward into regions of space that are receding faster than light can cross them, carrying its information into a darkness that no instrument you will ever build can penetrate. That light will travel forever, or until the vacuum decays and rewrites the rules, and it will carry forever the encoded history of structures that formed too early, too quickly, too impossibly, structures that the universe produced before anyone was watching and that continued to exist, indifferent to their own anomaly, long after the beings who noticed the anomaly are gone. You noticed, for a brief interval, in this particular corner of the cosmos, on this particular rock with these particular instruments, something looked up and paid attention and felt the full weight of what the looking revealed. Something followed the evidence into the dark and did not flinch from what it found there. Something held open the question even when the answer refused to come. That something was you. And the universe, which will forget you completely, which is already in the process of forgetting you, which has never once looked back, the universe, indifferent and vast and strange beyond all reckoning, continues.